participating, everybody. So let's go ahead and talk about that GRE, quantitative reasoning section. Let's go ahead and talk about it because there are four main mathematical topics here, right over here on the left. We have arithmetic, algebra, geometry, and data analysis. Those are the four main topics. And I'm going to dive into those a little more deeply with the practice that we do. Now, the types of questions that you're going to see, there are four types of questions that you will see on this test. So the first two, they're both multiple choice based, and so is the last. But there's a difference between them. So for multiple choice, they will give you the answer choices and you will select just one. For selecting all that apply, obviously there will be more than one answer, possibly more than one answer. For quantitative comparison, this is multiple choice. However, this is a unique type of problem where they will always present you with two quantities or two things, and they're going to ask you to compare their values, whether one is greater than the other, what the other is greater than that, they're equal, or you just can't determine the relationship from the information given. And numeric entry is where you actually type in your number and then you go move forward. Now, the two question settings that you are given are the pure math and real life. So pure math is where they honestly just don't have any context, no story. It is all pure math. And then real life, that's situational. And this is where everybody really hates their life. This is where they hate their life because not a lot of people can interpret the context quickly to determine what the solution is. So we will discuss a lot of real life problems along with some pure math, and we'll talk about how you can use that and benefit moving forward. So the topics of questions, they're split into 14 concepts. So hopefully you knew this, but if not, hey, no worries. Let's go ahead and inform ourselves because here they are, and here they are broken down. So in each test, this is a very, 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 very good depiction of the breakdown that you might see. And now please understand that yes, this will add up to more than 100%. Yes, and that's because you can have a word problem that is also algebra. You can have a word problem that's statistics, you can have some algebra problems that include ratios and proportions. So some concepts are mixed in together, and I hope you understand that. But you see how word problems, though, they make up 35.5% of your test. So that's something that you're really going to want to make sure that you pay attention to, because if you can't answer word problems, that's a third of your test. You're putting yourself at a disadvantage. But luckily, very luckily, we're going to be going over a strategy today. And this strategy is going to help you solve every single type of problem that you encounter. And it's called interpret, plan, compute. 3 steps, very short, very sweet. And let me go ahead and explain what this means. Think about in real life. So reflect on real life for just a moment and realize that, hey, in every situation that you have in real life, in every problem or challenge that you face, the best thing to do is to first interpret the situation, to understand what it is that's going on and what the problem actually is. That's what you do in real life. And once you understand what the problem is, then you think of a solution. You think about how you can solve this challenge, how you can move beyond this struggle. And once you think about how you can do it, you plan it out, right? You think about that plan, and then you follow your plan, then you execute. And that's what math, hey, it's the same thing here. Same exact thing. There's no difference. In every math problem, you first need to understand what it is that's going on. Then you need to make a plan. But you know what happens with a lot of people? And you tell me if this is true. How many of us here, and it's okay, it's going to be funny, but admit it. How many of us, when we read a word problem, we start reading the word problem, and then we see the first 2 numbers, we scramble, we grab our calculators, we start crunching numbers, we hope for the best, we sing a song, and we pray that the answer's there. How often does that happen to you? And the thing is, there you go, see some people raising their hands there. Yeah, and that's going to happen if we are not disciplined. We have to be disciplined about our approach. And being disciplined means not picking up your calculator first. Remember that your calculator is a tool. Do not pick it up before you are done understanding what it is that you need to do with it. All right, so that's the idea here. And I'm going to scroll down to show you the 3 steps. Interpret, understand the situation. identify the goal, and outline your steps. And lastly, execute your plan or compute. This is the last thing that you do. So take a moment, everybody, take a picture of this, write it down, because this is what we're going to be using with every single type of problem. So go ahead, go ahead, go ahead. Perfect. I see some people with their video on writing. I love it. I love it. Take those notes. Again, interpret the situation, plan, so identify the goal and outline your steps, and then compute, then calculate, then execute. So let's go ahead and move right along here, and let's talk about practice. So if you are ready to practice, give me a yes in the chat box, or give me an I'm ready to practice in the chat box if you are ready for this, because we're going to go over quite a few problems, as many as we can until 9 o'clock, because I respect your time. But let me know if you're excited. I love it. Yes, we're ready, we're ready, we're ready. There we go. So let's go ahead and make the most of this, guys. So here's my number one rule, though. We are not here to just sit back and relax. We're here to try. So make sure to try every problem, because here's the thing. If you're not trying, you're forfeiting your opportunity to grow. So if you are not here to try your hardest, guys, it's not gonna make sure that you grow. If you try, then you will be able to understand where you went wrong. And here, it's okay to be wrong. It's not okay to be wrong on the test, but when you're with me, it's completely okay. So try your best, and then we'll learn from there. So here is practice question number 1. A of 1 equals 2. A of 2 equals 7. A of n equals the quotient of A of n minus 1 over A of n minus 2. So what is A of 145? So go ahead. Typically speaking, the GRE allows 1 minute and 45 seconds per question. However, in this group tutoring session, we will begin with 2 minutes and 30 seconds for today. And then as we continue working along here, we will shorten that time to continue that progress. So I'm going to time us here, 2.5 minutes, go. And please, if you have your answer, do not type your answer until I say go. So keep your answers to yourself until we're ready. Try it out. All right, everybody, I'm going to allow an extra 20 seconds here. Wrap up. And if you don't understand the question or if you are stuck, get ready to take a guess. Just get ready to take a guess. And the thing is, you don't get penalized for wrong answers. So just another 25 seconds. All right, so that is time. That is time. So go ahead, reveal your answer. Go. What did you get? What did you get? So we have 722, we have 2, we have 2. What else do we have? What else do we have? 32. And again, guys, don't be shy. Please don't be shy. It's completely okay. Remember, admitting that we're wrong or admitting that we may not know is completely okay here, because there's the reason why we're here, right? If you were an expert at the GRE quantitative reasoning, you likely wouldn't be here right now. So just be okay with trying. All right, so we have 32, 290, 232, 2. Right on, everybody. So I'm going to reveal that the answer here is 2. It is 2. That is the answer. So congrats to those who got it right. But remember, it is not about getting one question right. It is about knowing that you can get the next one right. That is the point of this. So allow me to go over the question, and I'm going to use that strategy. Remember, interpret, plan, and compute. Those are the 3 big steps. Here we go. So let's go ahead. Again, if I read the question, I'm seeing that I have pieces of information given to me. I see that I have a of 1 equals 2, a of 2 equals 7, and then I'm given a relationship here to get the next term and the next term and the next term. And then I'm asked to find a of 145. So there is no context here, right? This is not a word problem. This is a pure math problem. And here's what I noticed. I noticed that instantly I have term 1. So, hey, look, my first term, my second term, and then I have any term right here that's given to me. And really, what we need to realize is that this is a sequence problem. This is an arithmetic sequence. So what we want to understand, or not, sorry, this is a recursive sequence. But nonetheless, this is a sequence, and I highlighted that right here. So when you are looking at a problem like this, here's a quick tip. This is a sequence problem. You guys notice that they gave you the first 2 terms, and now they want you to find what? The 145th term? So if you are stuck here, here's what you need to know. There will always be a shortcut method whenever they ask you to compute this many terms. They're asking you to compute 145. Wow. No, this will be a trick question. There is a strategy, a shortcut that you can use, and let me show you what it is. So I'm interpreting this. It's a sequence. I'm going to have to figure out the 145th term. What's my plan? Well, I know the trick is there has to be a pattern. There has to be a pattern because there's no way that I'm going to calculate 145 terms. I don't have the time for that. So there's my plan. Figure out what the pattern is. To figure out what the pattern is, let's just go ahead and solve for the next couple of terms and see if we can notice a pattern. So everyone help me out. If the first term is 2, the second term is 7, and the next term is the previous term divided by the other previous, the second previous term, how are we going to get a of 3? How do we get this? What are we dividing here to get a of 3? Correct, Tisha. Yep, that's going to be 7 divided by 2, because the a of n minus 1, that means the previous term, which is 7. And then a of n minus 2, that is the previous term. So 2 terms ago, which was 2. So we are dividing and we receive 7 over 2. So everybody, if you were confused by this problem, do you understand at least now what that means, what this means in terms of what it asks you to do? Which means, again, take the previous term and divide it by the second previous to get the next term. So let us know, yes or no. If you were confused before on that part, let me know if that makes sense so far. Because moving forward now, here's what we got. We're now going to go ahead and find a of 4. So here, what we're going to do now is figure out, hey, to get the 4th term, remember, just follow the rule. We will take the previous term and divide it by the second previous term, which was now 7. So from here, now let's go ahead and simplify this. So here's one way that we can simplify. When you're just dividing by one number, so let's say you have the fraction 7 over 2, and you're dividing by 7, you can essentially say that you're dividing by 2, then dividing by 7, which is the same thing as saying dividing by 2 times 7. Another way that some of us might recognize this is the keep, change, flip method, which is treating 7 over 2 as one fraction and treating the 7 as 7 over 1. Because when you divide fractions, you will go ahead and keep the first fraction, change the sign, so divide, change to multiply, and then flip the second fraction. They both result in the same thing, because what we have here is 7 and 7 canceling, giving us 1/2. 7 and 7 canceling, giving us 1/2. So we get the same result either way, just making sure that we understand that. But nonetheless, 1/2 is the result for A of 4. So here's the thing. We don't see a pattern quite yet, right? This might deter some of us, but keep going because again, we have to trust that we are guaranteed to see a pattern. We are not going to count to 145. So up next, let's go ahead and find out what A of 5 is. So A sub 5, everybody help me out. What are we dividing by what? So use the pattern again, use the formula. What are we dividing for A of 5, for that 5th term? What are we dividing? No worries, no worries, no worries. So, all right, it looks like some of us are giving out one fraction, some are giving out 2 fractions. But yeah, so again, yep, what we have is, again, take the previous term and divide it by the second previous term. And so what this will equal, again, we will just complete our method, keeping, changing, and then flipping. And so this will allow us to receive 1/7. Boom, just like that. Yep, exactly. We get A5 by dividing A4 by A3. Perfectly said, Oppo, perfectly said. So there we are. So now I can erase all of this and get 1/7 as my next term. Again, we don't see the pattern quite yet, but don't worry. Keep it going. A of 6 now. So A of 6, what we will do, and I know that some of us may not be able to see this fully, so I'll move this over here. So A of 6, let's try that one out. Again, we will take A5 and divide by A4. And so this will give us 1/7 multiplied 2/1 gives us 2/7. So I erase all of this again, and I will move this over. Last time, again, we need to find the pattern. I don't see it yet. So now I will complete A7. I will take A6, divide it by A5 to receive 2/7 multiplied by 7/1, which gives us 2. Oh, look at that. Look at that. Here's what's interesting. A of 7 and A of 1 are the same. Pretty interesting. Let me just make sure that there is indeed a pattern. Let me look at A of 8. That means that I will take A of 7 and divide it by A of 6. So that will give me 2 multiplied by 7 over 2. The 2's cancel, leaving me with 7. Look at this. Everyone, do we see the pattern now? Do you see what's going on? Exactly, Divya, exactly. This pattern will continue. This pattern now repeats. It is repetitive. And what I want you to see is that, hey, look, after every 6, this is where it starts repeating. After every 6, it repeats. So what does this tell me? This means that we need to divide 145. We need to see how many times 6 fits into 145. So here's what you want to do. You want to use your calculator at this point, because now we've identified the pattern. Every 6, it repeats. So this means we need to figure out how close to 145 we can get with 6, and then keep counting from there. So with that said, that's exactly what we'll do. 145 divided by 6, if you grab your calculator, you'll see that it is 24.16 repeating. And this actually doesn't matter. All I know is that it fits into 24 or into 145 24 whole times. So grab your calculator again. 6 times 24 is 144. So this means, what this means, and I'll erase this here. What this means is that my A of 6 is the same as A of 144. Because again, it's the multiple of 6. Every 6, you'll have that number, the 2 over 7. So if this means that we're just following the sequence, what would A of 145 be? What would the next term be? And so with that said, that's the next term right there. It's 2. Boom, we're all set. And so that's how we get the answer. So those of us that got it correct, did you understand every step in this way? Did you realize anything that you could have done differently? Those of us who were quite confused in the beginning, let me know. Do you feel that at least part of this made sense, whether it was interpreting that it was a sequence, the plan in trying to find the pattern, or executing quickly to figure out what that pattern was? Clear now? Perfect, guys. I appreciate that. And Mr. Khan, it seems like the question was from functions questions. Yeah, there was a little issue with when we transferred it from the notes that we had to the slides. It looks like this is not right. It looks like it is in function form, so I apologize for that. It will not happen again, I promise. All right. But thanks, guys. I love the kudos for the explanation. So with that said, that was arithmetic. Let's go ahead now and let's try another question. Let's look at number 2 here. This one is from algebra, especially rates and linear equations. This is a word problem now. So again, I will give us 2 minutes and 30 seconds. 2 minutes and 30 seconds to answer this question. Read it carefully, try it out, and remember to not share your answer until I say so. Go. No worries. And even if you know this question, I want you to work on your explanation. because there are going to be times where you do the same problem twice in practice, but it's about how you utilize that problem that is going to ultimately benefit you the most. So work on your explanation. See if you can go through all three. All right, we have 30 seconds left, 30 seconds left. So again, even if you got it right, make sure you know how to explain it appropriately and correctly. And hi, Gatiti, just to address your concern there in terms of speed, my goal here is to make sure that everyone feels welcome and everyone, no matter where they are skill-wise, can make progress. So I do understand that you are in an advanced level here, so I commend that. I appreciate that. I just want to make sure that everyone else as well has the opportunity to learn the same as you, all right? So I do apologize if you feel that I'm moving a little slow, but my concern is to make sure I address everyone, including you, okay? So thank you for your patience. And 4, 3, 2, 1. What are our answers? Hit me. What do we got, guys? What do we got? We got 30 minutes, 30 minutes, 30 minutes. Okay, looks like a lot of people were pretty confident about this one. We may have seen this problem on the Scholar Den website, right? I love it. I love it. But the thing is, I'm not afraid to show those same problems because, again, it is not about getting one problem right. It's about knowing how to get the next one right. That's the most important part of this. So let's go ahead and let's review. So we have one person with 40 minutes here, the 30s. Just got blank. See, okay, so not everybody knows, and that's completely fine. The answer to this question is 30 minutes. It is 30 minutes, guys. So let's review how we get that right. So here again, we're going to use this 3-step strategy. Look at the context, then look at the content, then compute. Interpret, plan, compute. So the first step here is to interpret. What I want to do first is read the problem without the math, without the numbers, just the situation. I just want to know the story. So I'm going to read the problem without talking about the math. Watch this. So we're talking about a train that travels in a particular direction at this speed. It then travels at another speed for some time. On the return journey, it goes the entire distance in the opposite direction at another speed. So how much shorter is the time of the return journey in minutes? So notice how I did not even talk about the numbers, because again, it's not about the numbers, it's about what the numbers mean. And we see that we're discussing a train traveling in one direction, then it travels at a different speed, and then it comes back to its original starting point. So train goes and then comes back. Pretty simple, right? I think we can imagine that. Now we have to understand what the question is, though. So I understand that we're going back and then forth, okay, but what's the question? Well, it says, how much shorter is the time of the return journey in minutes? So everyone, let me ask you this intuitively. So from your understanding of real world, if I ask you how much shorter something is from something else, what do you think of mathematically? When I say how much shorter is this and that, what math are you thinking of? What simple math are you thinking of? If I say how much shorter is this than that? Yeah, Amir, subtraction, Chirac, subtraction, Deo, subtraction, exactly. We're thinking subtraction. If I say how much shorter is this than that, I'm thinking I need to subtract this and that. So boom. So that's what I'll do. I'm taking the difference. So that's my interpretation. I've interpreted that I need to take the difference between two things. And so what are those two things? Well, let's go ahead and write that out right now. We are taking the difference between, we see here, return journey and then the traveling to. So we're going to subtract time there and time back, or the return. So that's my interpretation. I've interpreted it correctly. We're good now. Now it's time to plan this thing out, because now the question becomes, how do I get the time there? How do I get the time back? How do I get those things? So when I take a look, which one's easier for us to figure out? To get the time there or time back? So let me know quickly. Which one's easier, to find the time there or the time back? So we say the difference to get the time back. Oh, are you sure? So when we look at the information that's given, let me go ahead and erase what I've already highlighted. So let's look at the information. Let's see which one's there, which one is easier. So looking at the time there, I see that it travels in a particular direction for 50 miles an hour for 2.5 hours. Then 40 miles an hour for another 2.5 hours. Now we're talking about the return journey. So with the return journey, entire distance, 50 miles an hour. So think about it. The time there, they give it to you, 2.5 hours and another 2.5 hours. So how much total time is that? Exactly, guys, it's 5 hours. We see it here, 2.5 hours and 2.5 hours. Boom, we have that, we're good. So we already have the time there, we're good. Now we just need to figure out what the time back is. So now the question is, how do we get that? So here's where I'm going to introduce this formula that you're gonna wanna use when dealing with rates. So the formula for rates is the distance equals rate times time. And so if we want to know how much time it'll take us to get back, well, we see here that he travels at 50 miles an hour. So return trip, I'm going to write that in blue. He's traveling at 50 miles per hour. So in order for us to find how much time the return trip took, we see that we have the rate of 50 miles per hour. We need the distance. We need to find the distance. If I don't have the distance, then I can't find the time. So let's find the distance. Well, we see here that on the two trips, so on the time there, if we are going 50 miles an hour for 2.5 hours, what do we do with 50 and 2.5 to find the distance? What do we do with those two things, guys? Quickly, quickly, quickly. What do we do? With the 50 miles an hour for 2.5 hours, what do we do with the 50 and the 2.5? What are we supposed to do? Multiply, exactly. Thanks, S. So we will multiply. So 50 times 2.5 gives us, that would be 125 miles. So that's one of them. Now we see over here that we have 40 miles an hour. So I'll actually go ahead and take all of this down here with me. And with the second one, we see here that we have 40 miles an hour. For how long? Another 2.5 hours. So again, just like we did last time, we'll multiply again to get 100 miles. So again, why was that important? Well, remember, that was important because we wanted to know the total distance, because we know how fast the train is going on the way back. So together, that creates 225 total miles. And again, that is the distance. So now we can feel confident about finding that time, because 225 miles, this is what we're going to set up now. 225 miles equals the return rate, 50 miles an hour, multiplied by time, or t. From here, all I have to do is divide both sides by 50, and we will receive t equals what? What do we get if we divide, guys? T equals what? Go ahead, help me out. Yep, divide, and we get t equals 4.5. Perfect. Thanks, Abdul. So that's 4.5 hours. So look at that, 4.5 hours. Perfect. We have now filled in our plan. Guys, remember, this was the goal the whole time. Time there and time back, and now we did that. Now we're good. 5 hours minus 4.5 hours gives us half an hour. And we know that half an hour translates to 30 minutes. And that's why C is the answer. And there we go. So let me know, did we, even if we got it right, do we understand the process a little more, with a little more discipline, with a little more structure? Because that's the goal here. I don't want us to waste time when we're solving these problems. You have to go from step A, which is, hey, interpret, then make your plan, then compute, not any other order. Perfect, no worries. So let's go ahead and dive right into question number 3. I want to make sure that I can at least get one more question in before the session ends. And then I'm going to ask everybody if you want to do one more after that. So here we go. Question 3. So this is from geometry, and the skill is two-dimensional geometry, two-dimensional shapes. So again, 2 minutes, 30 seconds, and go. Remember that we should be aiming to get 1 minute 45 eventually, but we're going to start off with 2.5. Go. This is quantitative comparison. Yeah, Apurva, I got you. Yeah, so I scaled it up over here to make sure that we could see, but I will go ahead and write it out for us here. So this is 0, y. This one right here is x, comma 0. This one is 2x, 0.5y. And this one is 3x and 0. There we go. Hopefully that helps. All right, so keep it going. Remember, don't share answers until I say go. All right, we're looking at 20 more seconds here, guys. Keep it going. I love it. Some of us think that this is easier than the other ones. It's completely understandable. Remember, interpret, plan, compute. Interpret, plan, compute. That's the process there. All right, and 3, 2, 1, go. What are our answers? Okay, we got some C's, some B's. All right. Some A's, some B's, some C's, some A's. So I want to remember who said that they thought that this was easy, but clearly not, because we are all having different answers, right? We all think differently of this problem. So I hope that we can chuckle a little bit at that, right? That was funny because someone they thought it was easy. But again, what's easy to you is not easy to everybody else. So when practicing, remember that, especially if you're studying with a partner or a group. So let's go ahead and go over this question. The answer is C. The two quantities are equal. It is C, yeah. So let's understand why that's the case, because I know that some of us that got C probably guessed, so I don't want that to happen. So let's take a look here. Let's go through the plan. Remember, the context or interpret. Step one, let's read the question. I'm looking here and I see, okay, I'm looking at a graph. I'm looking at a graph. I don't know what this means yet, but I'm just looking at a graph and I see that we have, these lines there, whatever. I see that we have points A, B, C, D, but again, work quickly. I just see a graph. What am I trying to find? Look at the quantities. Oh, they both say area. And in quantity A, it's the triangle OAB. With quantity B, it's triangle BCD. So with this said, what we're going to want to do is, well, to compare the quantities, we have to take the areas. Now, when it comes to quantitative comparison questions, this is an example of it. Quantitative comparison questions, it's going to be one of the four answers, obviously. But the thing is, you have to look out for the conditions of the problem. If the conditions of the problem are very strict, that means that you will likely have a solid answer. It might be A, B, or C. However, if it feels loose, or if it feels like they don't describe everything as fully as they could, the chances are it's D. So eventually in other group tutoring sessions, we will go over those types of examples, very much so. But here we go. Let's try to find the area of triangle OAB. And that is right here. OAB. So that's this triangle right here. So remember, let's remind ourselves, the area of a triangle is 1/2 of the base times the height. If you didn't know that, well, now's a good time to write that down. So the base is the horizontal length, the height is the vertical length. So let's go ahead and do this for quantity A. So the area equals, well, what's my base and what's my height? So for A, if I take a look here, well, the base would be the distance from here to here, which, if we're looking at the X values, we see that we're going from 0 to X. So the base would be X minus 0, which is X. Now with the height, we are going to see how far up we go. From 0 to Y, because remember the origin is 0, 0. So that's why I am referencing 0 a lot. Now, if we're going from 0 to Y, again, the height would just be Y. So the area for this first triangle, OAB, is 1/2 of X times Y. Now, let's go ahead and take a look at quantity B. So for quantity B, for triangle BCD, again, we will need to determine what, and I'll use a different color here, purple. We'll need to determine what the base is and what the height is. So let's go ahead and take a look at the base first. I see here that I'm going to make this a little thinner. I see that I'm going from here to here. That's where I'm going. So notice how we're going from X to 3X. So to get that distance, we want to subtract to see what this will give us. So this will provide us with 3X minus X equals 2X. That is my base, 2X. So far, before I continue, everyone, please let me know. Is that, are we getting this so far in terms of finding the base? Give me a yes or give me a no, I'm still confused. Just, be honest. I really want you to be honest, because I'm not here to just talk to the wind, I want to make sure that you truly feel comfortable. All right, perfect, sweet, thank you guys. So now, time to find the height. So the height, I'm observing this and I'm saying, okay, we're going from 0, because this is the x-axis, this is flat, and I'm going all the way up here. So we're going all the way up to 0.5y. So that's what I'll have, 0.5y, just like that. So boom, I have my base, I have my height, I can go ahead and find my area. Remember, my area is 1/2 base times height, which means that we will have 1/2, and let me just move all of this over down here. So we will have 1/2 of the base times the height. Just like that. And boom, from there, now we can simplify and see what we get. So I see that if I go ahead and distribute 1/2 times 2x, well, that will give me 2x over 2. Oh, that's going to cancel out. And so it's going to give me x multiplied by 0.5y. And that is the same as saying 0.5x times y. Now, let me ask everybody, are these the same? 0.5y and 1/2 xy, are these the same? Yeah, they are. They're written differently, right? They're written differently. But guys, look, go ahead. 1/2 in your calculator translates to 0.5 xy. So these indeed are the same. And we did this properly. We computed the area with what we had. We did everything right. We had our interpretation, triangles, area, had our plan, find the base and the height to find the area. And then we computed by actually looking at the graph and finding those values and plugging them in. Notice the strategy works for word problems and it works for all math problems. So are you guys excited about that though? Because I am really excited about being able to use that strategy for any type of math problem. It really is exciting to me, at least. And even if you've seen these problems before, thank you. Even if you've seen these problems before, that's the point. Knowing that you can get the next one right because you understand this one so well. So I want to thank everyone for coming. So allow me to wrap up here. I know it's 9:03. I want to respect your time and make sure that you get on with your day. So I did have other problems planned, but that's okay. I'm going to host another free session very soon. So stay tuned here so you can learn when that is and how you can sign up. But in the next free session, we will be going over these more problems here. But first of all, how do you feel? How did you feel about this session? Let me know, guys. Was this presentation useful? Because I really, really need to know for my sake and for your sake. Looking forward to more tutorials. Hey, I appreciate that. Easy now, but when you're doing it alone, you don't know what happens. Hey, that is exactly what I mean when it comes to the discipline. You need to use the plan, the strategy every time. And eventually it will be easier and easier and easier. I promise you. Another one soon, please. Yeah, for sure. Extremely helpful, useful. Yes, I appreciate that. Yes. Awesome. Yeah, thankful, helpful. Perfect, guys. I appreciate that. Yeah, sweet. I'll be hosting more sessions, so go ahead and stay tuned here. Yeah, well, I'll go ahead and make plenty more. So remember, guys, take a picture of this if you didn't. Please take a picture of this. Standard deviation mirror, perfect. I'll go ahead and keep that in mind. I'm going to give you a survey that I want you to answer to allow me to see what problems I should do next. But remember, guys, every question can be solved using this 3-step formula. So take a picture of this. Take a picture of this. So moving forward, here's what we want to do. Here's what you need to do to make sure that you're doing the right things to raise your score. First of all, you want to familiarize yourself with the test and concepts. All right. So I went over that briefly in the beginning, but there's so much more that you can do. Next, you want to practice consistently and with strategy. Again, that strategy that I just showed you, practice every problem with that strategy. I promise you, a lot of us feel anxiety when we start doing math problems. We feel kind of nervous. And that's because we don't always know where to start. And that's okay if you don't know where to start, because I'm teaching you how to start. Does that make sense? Again, you may not know where to start, but you will always know how to start the problem. And that is invaluable. And so, time yourself to simulate the test environment. So with that said, 1 minute 45 seconds per question is what you're looking at. So if you can get down to that time to complete every problem, you are in a very, very, very good spot. If you're not doing that, if you're not timing yourself and you can solve every problem, that's cool. But what's going to happen on test day, right? You want to make sure that you can time yourself the right way here so that when you take the test, it doesn't feel any different. You've been doing the same thing you've been doing this whole time.